So hey guys, today we'll be doing something called KMeans clustering, and clustering is basically you take data and you form clusters of data where like each cluster have some attribute close by to the next to the other value in the same cluster. So we'll be doing this clustering on a list of songs, attributes of songs found on Spotify. So you can see we have various columns like genre, artist name, track ID, but we won't be using that. We'll be using these attributes: acousticness, danceability, duration, energy, instrument, key, liveliness, loudness, mode, uh, speech, tempo, time signature, and variance. Time signature also we won't be using because it's just a date. We won't be needing that. Cool. So let's get into it. First, we'll call all the modules. I've already called the modules, and then we'll import the data set. Data set is equals to panda dot read csv. We've been using that before also, and our csv's name is spotify.csv. And then our data set will drop. So let's just run and we'll see how the data set is. Save it here. Yep, so when we run it, you can see here on the variable explorer data set. So it has all these. We won't be needing this so we'll just start dropping those columns. Let's keep this aside, and then let's just use the data set dot drop and we just leave it empty for now, and we'll use the in place as true. So in this we'll be adding the column index which will be dropping. So we'll be dropping the 0th 1 2. So we just add that 0th 1 2, third one also, so comma 3, and then all we need popularity and all that, so we just keep that, and we won't need a time signature, so I'll remove the -2 value. Cool. And yep, so it's done. No, this true should be. This should be true. And then after that, so we have our x right now. So x is just data set. We won't even need to store it in another variable, but let's just do it for clarifying things. So look, we don't have the names and all that. It's all gone. Time signature is also gone. So we have only the important stuff, popularity and all that. So what we'll be doing now is we'll be doing something called column transforming using one hot encoder. So you see all these values are there again and again, like C. So no, so this is like major and minor. It has only two values, so that can be converted into zeros and ones. So 0 signifies major and minor signifies 1. So same way we can do it for this column as well. So this is column number 6 and this column number 9. So we'll be doing that. This is called one hot encoding. So let's just call the function. One hot encoding is very important since It will help us remove all the strings and convert them into zeros and ones, and it will be easier for computer to understand. Instead of strings, we'll be giving them integers, so it'll be easier for it to understand. So we'll be using scikit-learn module sklearn dot using column transformer, and this should be from, and we'll be using a scikit-learn module called preprocessing to call one hot encoder. So from that, we'll be using preprocessing import one hot encoder. So cool. Now we store the class in a variable, class variable ct call a transformer, and then we'll be defining the transformers value attribute. So transformer should be equal to, it should be in a tuple, a list with tuples, in which the first should be the encoder, and then in second one we want one hot encoding, so one hot encoder, and we want to remove what all. We just check it here. It's the -1 2 3 4 -4 5 6 and -4 and -7 from last. So from last this is 4th and 7th, so we put -4 and -7 in a list. So minus, yeah, so this part is done. Now what we'll be doing, we'll be fitting the column transformer. So x underscore train will become ct numpy array, and p dot array of ct column transformer, the class variable which we have made, and we're gonna fit it. So we're gonna call the fit transform, and then we're gonna fit it with the variable x. Cool. Now we do it, let's just run and check. Column colm dataset dot column. Should be columns since it's multiple. This compose as compose. So fit trans. So lot of spelling mistakes today, huh? Yeah, so you see we have x train here right now. X train is returned, and we have to add something called remainder passover. So what it does is it will let go whatever is supposed to be passed on by the, like whatever value should be ignored. So we just type that remainder is equals to pass through, otherwise your list will just be empty, or it will have only like all the unique values once, that's all. So this part is done, and this encoder is also fine. So now you see, okay, so you can see like all the attributes are converted to zeros and ones, zero, 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 and ones. So all the data which we've given is converted to zeros and ones, and all the data which we didn't like check touch is still there how it was before. So it didn't make any difference in that, and we didn't change anything. And now the easy part is just calling the module and just fitting it for sklearn dot cluster import KMeans, and we'll just make the KM variable and KMeans, cool, and the number of clusters which we want, that we have to use something called the elbow point. We have to find the elbow point. I'll leave the function for that in the description. I'm not giving it here since we cannot use it without doing another stuff on the data. So I'll just drop it in the comments description, and in it should be KMeans plus plus, and we want the random state to be like a random state, how random the data will be picked up to train the data set. So we can keep it at 5. Is there another? KMeans has M capital, and we'll keep it at how we want 10 clusters, so we'll keep at 10. We want to form 10 clusters, so we'll keep that as 10. And then y underscore means will just be get the km, and we'll just fit it. So we'll just fit x x train, so x train, and that's all. We are done. And it should be n clusters, sorry, so it will be n clusters random, and this should be a random state, not random. So syntax error is very normal actually. It can be done by anyone, just typing error. So it's just fitting the data. It's taking some time to do so because we have like, you see how many values we have in this. We have approximately like 2,32,000, 33,000. So yeah, it's done. Depends on your system also. My system is pretty powerful, still it's taking that much time. Now when we print y means here on our terminal console, so it shows we formed 10 clusters and the random state is 5, and then we can get the cluster points as y means dot clusters underscore. So I'll just, it should be clusters underscore. Okay, that's giving an error. Let me just check the syntax. So to get the clusters centers, the command is y means, and the cluster underscore centers. Center. So you can see we have an array with sub arrays which has the number of points which is given, like not x. Yeah, so we'll have all these like 25. We have 25, so this will be 25, and the coordinates is a 25 dimensional data. It has 25 dimensions, and we have like the first center for the first cluster is having these coordinates, and then the other center for the second cluster is having this coordinates. So for example, you can see here, imagine this is one cluster, this dot is the center. So the center point for our data set, their data set is just 2D. Our data set is 25 dimensional. So the 25 dimensional points are this. So this cluster's point will be this, and this cluster's point will be this. This cluster's point will be this. So like this we can make the cluster and find like what type of music is relatable to each other. Like that we can do. So it'll be easier for us to make playlist. If you want to make a playlist on Spotify, we can take this data and we can make playlist of songs in this cluster, and then songs in this cluster, because similar people may like the songs in this part, and similar people might like a song in this part, who like this much audibility in this much loudness, like that. So I hope you understood. I know it was a bit confusing since it had 25 dimensions, but it's a good example to understand how clustering works and how we can use clustering in real life applications. So I'll meet you in another video, and if you want any other resources for any other video, I can just drop it here. Like if you want any code or anything else, I can just drop it here. Till then, bye bye, take care, and yeah, bye.